Hello class 10 students. So আজি মই তোমালোকৰ লগত ফিজিক্সৰ এটা খুব ইম্পৰ্টেণ্ট চেপ্টাৰ ষ্টাৰ্ট কৰিম। এই চেপ্টাৰটোত একচুৱেলি মেক্সিমাম ষ্টুডেণ্টছৰে ডাউট থাকিব পাৰে, চবৰে নহয়। চ' চেপ্টাৰটো হৈছে ইলেক্ট্ৰিচিটি। আই নো ৰাইট, এটা খুব ইণ্টাৰেষ্টিং চেপ্টাৰ। আমি জানো যে মডাৰ্ণ ছ'চাইটিত ইলেক্ট্ৰিচিটিৰ ইম্পৰ্টেঞ্চ কিমান। যিহেতু ইলেক্ট্ৰিচিটিটো কণ্ট্ৰল কৰিব পাৰি আৰু এটা কনভিনিয়েণ্ট ফৰ্ম অফ এনাৰ্জি, চ' সেইবাবে আমি আমাৰ স্কুল, কলেজ, ঘৰত, ইণ্ডাষ্ট্ৰিজ, হস্পিটেলছ এক্সেট্ৰাত ইউজ কৰোঁ। চ' এতিয়া ইলেক্ট্ৰিচিটি হয় কি? ইলেক্ট্ৰিচিটি বুলিলে কি বুজা বা কি ফেক্টৰ্ছৰ ওপৰত ডিপেণ্ড কৰি সেই ইলেক্ট্ৰিক কাৰেণ্টটো ইলেক্ট্ৰিক চাৰ্কিটত ৰেগুলেট বা কণ্ট্ৰল হয়, বা কাৰেণ্টটো কেনেকৈ ইলেক্ট্ৰিক চাৰ্কিটত ফ্ল' হয়। চ' এই গোটেই কুৱেশ্যনছবোৰৰ এনচাৰ্ছ আমি এই চেপ্টাৰটোত এটেম্প্ট কৰিম। চ' ৱেলকাম টু লেকচাৰ নম্বৰ 1. So students, now tell me, what do you mean by electric current? But first of all, you should know what is current. Simple language ot current to hoise jetia eta object ba body definite direction ot move hoy ba flow kore take current buli koy. Now for example, when water flows from one place to another, it is called water current, and when wind flows from one place to another, it is called wind current. So itia ami water current aru wind current or logot familiar, right? So similarly, electric current to hoise jetia eta electric charge conductor flow hoy. Conductor, for example, a metallic wire. So a metallic wire through this electric charge to flow hoy, we can say that there is electric current in the conductor. Now let us see the definition of electric current. Electric current is the flow of electrons in a conductor. So itia conductor to ki flow hoy? Yes, the flow of electrons. Or we can define electric current as it is the amount of charge flowing through a particular cross section area in unit time. So itia eta cross section area unit time ot jimantu amount or charge flow hoy take electric current buli koy. Now see the cross section area. So this is a conductor, for example a metallic wire. Itia ami jodi he metallic wire dal majote kati diu, there we will get a cross sectional area, as you can see here. So now electric current equal to amount of charge per unit time. Clear? Now let us see what makes the charge flow. So itia metallic wire charge to nije flow hoy na jay, right? So let us consider the analogy of flow of water. Now consider two tank A and tank B. So itia tank A to tank B comparison otke upor thua hoise, as you can see here, right? Now connect one end of the tube to the tank of water kept at a higher level, as you can see here, right? So itia ki hoy swa duta endor majot pressure difference hoar karone tank A para tank B le water to flow hoise, right? Aru ami janu je eta perfectly horizontal tube ot water to flow na hoy. So jodi he tank A aru tank B to ami same level ot rakhilu heten aru a tube to horizontal hol hoy, tetia tank A para tank B le pani to flow hoy nahe, because there is no pressure difference. So ita mainly he pressure difference to hoar karone tank A para tank B le flow hoy ahise. Clear? So tank A, it has a higher temperature of 60 degrees Celsius, and tank B, it has lower temperature, that is 20 degrees Celsius. Okay, now let us see cell. So ita ami janu je cell tut eta duta terminal ase, right? Positive terminal and negative terminal. Now this positive terminal, it has higher electric potential, and the negative terminal, it has lower electric potential. So ita a cell to a tank or nisna actually, so it is similar to the tank. Positive terminal, it acts as a tank A, which has a higher temperature and it has higher electric potential. So similarly, the negative terminal, which acts as tank B, it has a lower temperature and so it has lower electric potential. The difference between higher potential and lower potential is called potential difference. So it a potential difference to hoise a higher potential aru lower potential is into difference, head to a potential difference. Clear? The function of the cell is to create potential difference. So itia cellor main function to hoise he potential difference to create kora. Am I clear? All right. Now what is a free electron? So now say this is a nucleus, and we know that a nucleus is made up of protons and neutrons, right? So protons have positive charge and neutrons, they have neutral charge. So overall a nucleus or charge to hoise positive. And now see these are electrons. It is so ami janu je electrons or charge to hoise negative. Now say between the nucleus and electron there is a force of attraction called electrostatic force of attraction. So এটা যেহেতু পজিটিভ আৰু নেগেটিভৰ মাজত এটা attraction হয়, so similarly nucleus আৰু electronsৰ মাজত এটা force of attraction আছে. হে force of attraction টোক electrostatic force of attraction বুলি কয়. Clear? Now say in non-metals the number of electrons in outermost orbit is more. So এটা non-metals যেনে nitrogen, oxygen এইবিলাকত electronsবোৰ outermost orbitত বেছিকৈ আছে. That is 5, 6, 7 electrons in their outermost orbit. Hence, electrons are strongly bound. So, যিহেতু এতিয়া এই non-metals ক্ষেত্ৰত electronsবোৰ outer orbitot or outer cellsত বেছিকৈ আছে, so সেই কাৰণে electronsবোৰ strongly bound হৈ থাকে. আৰু সেই electronsবোৰ easily ওলাই নাযায়. In fact, in case of non-metals, they are more likely to gain electrons. Clear? But in case of metals, the number of electrons in outermost orbit is less. So, it metals like iron, copper, এইবিলাকত electronsবোৰ outermost orbitot কমকৈ আছে. That is 1 to 3 electrons in their outermost orbit. Hence, the electrons are lightly bound. So, it metalsৰ ক্ষেত্ৰত যিহেতু electronsবোৰ outermost orbitot কমকৈ আছে, so সেই কাৰণে it easily lose electrons from their outermost orbit. Clear? And the metals, they are less likely to gain electrons. Okay, I hope everyone understood. Now say, depending on the number of free electrons, substances are classified into conductors. So conductors, they have large number of free electrons which are charge carriers. So materials with electron mobility, that is free electrons have electron mobility to high, heblake hoise conductors. The second one is insulators. So insulators have less or practically no free electrons. So materials with electron mobility to bahut kom or few or no free electrons, they are called insulators. And the last one is semiconductors. They do not have free electrons at room temperature but can develop under specific condition. So it is conductors borat free electrons normally room temperature nathake. But under specific condition, semiconductors bilake free electrons create koribo pare. So SIM card is made up of semiconductor and IC, which is integrated circuit. These are the examples of semiconductors. Now let us see few MCQs. The first one is a substance which does not allow charges to pass through it easily is called. So can you tell me what is the correct answer? Of course, it is insulator. So we know that insulators, they do not have free electrons. So যিহেতু insulators বিলাকত free electrons নাথাকে, so definitely that charge to পাৰ হ'ব নোৱাৰে. Okay? Now let us see the second question. Negative terminal is called, of course I marked the answer only. So it is lower electric potential. We know that, right? Now see the third question. Substances which do not have free electrons but can develop under specific condition are called. Yes, right, that is semiconductors. So আমি এটা জানো যে semiconductors বিলাকত normally যোনটো room temperature হেতুত electronsবোৰ freely নাথাকে, right? But কিছুমান under specific condition like by imparting heat, তেতিয়া তাহাঁতি সেই free electrons to develop কৰিব পাৰে বা create কৰিব পাৰে. Now see the last one. The function of the cell is, yes, it is to create a potential difference. That is, the cell creates potential difference. So cellular hetu eta main function. Alright, now see here, flow of current in a wire. So consider this is a wire and these blue dots, these are atoms. Alright, so atoms, they are in the state of vibration and the black dots, they are electrons. So the free electrons in the state of random motion. Okay, now see here, connect this wire in a circuit as you can see here. So etia a wire dalot current to keneke flow hobo. So jetia ei duta endor mazot eta potential difference thakibo, tetia he wire daledi current to flow hobo. So etia ei potential difference to kune create kore? Yes, it is the cell. The function of the cell is to create the potential difference. Aru ami janu je conductor ki flow hoy? Yes, conductor electrons flow hoy. So electrons bur so keneke flow hoy? Electrons move with a certain average drift. So electrons bur eta certain average velocity move kori thake. Clear? Now see the direction of the free electrons. the flow of free electrons from negative terminal to positive terminal. So এতিয়া এই free electrons বোৰ negativeৰ পৰা ওলাই positiveত সোমাই গৈ. Whereas the conventional current, it flows from positive terminal to negative terminal. So guys, don't get confused between the free electrons and the conventional current direction. Free electrons for negative or para ulai positive hot humai goi, aru current to positive or para ulai negative hot humai goi. Clear? Now let us see potential difference. So this is an insulated stand A which has positive terminal, and we know that positive terminal has high potential. And this is an insulated stand B which has negative terminal, and negative terminal has low potential, right? So etia insulated stand A aru B er majot edal metal wire connect kora hoise. So this metal wire is acting as a conductor. Now see, due to difference in potential, charge will flow from higher to lower. So etia potential difference thokar karne charge to high potential or pra low potential le flow hoise. So as charge is flowing, work is done. So jetia charge to flow hoise high to low, tetia tat eta work done hoise. Now let us see the definition of potential difference. The electric potential difference between 2 points in an electric circuit is defined as the amount of the work done in moving a unit positive charge from one point to another point. So etia electric circuit etat duta points or mazot eta unit positive charge eta pointer para hitu pointole move korute jiman to work done hoy take potential difference buli koy. Am I clear? Alright, next we will see how does lightning occur. So etia normally ki hoy, most of the time positive aru negative charge pur eta objectot balanced hoi thake. Okay, but clouds, they have static charges. So static charge mane hoise he objectot setia he positive aru negative charge to balanced hoi na thake. That means static electricity is an imbalance between negative and positive charge. Clear? And the clouds, they have static charge. Therefore clouds are at high potential and the earth is at zero potential. So it is generally ki hoy, earth to eta infinite body, right? So generally infinite body hole potential to zero thake. Okay, so it ami janu je charge to high potential to low potential le flow hoy. So similarly in lightning, charges travel from high potential to low potential, and this is how the lightning occur. Now let us see few more MCQs. The first one is, the electrons flow from negative terminal to positive terminal of the cell, but the dash of current is from positive terminal to negative terminal of the cell. Okay students, now can you tell me which is the correct answer? Yes, it is A, the conventional direction. Etia ami janu je free electrons bor negative or para ulai positive hot humaige, right? But conventional current to positive or para ulai negative hot humai. So both are in opposite direction. So see here, the conventional direction of current is opposite to the direction of flow of electrons. Clear everyone? Now see the second question. The function of the cell is to create okay, it's an easy question. Yes, the function is to create a potential difference. So as cell contains high potential and lower potential. Now see the last question. The potential of earth is, yes, it has zero potential, as earth is an infinite body. So guys, now we will see physical quantities. Anything that can be measured is a physical quantity. So jetia ami eta bostu physically measure koribo paru take physical quantity buli koy. For example, distance is a physical quantity. Eti ami kiman dur khos kahilu ba kiman dur dorilu he distance tuk measure koribo pari, right? So he karne distance tu hoise eta physical quantity. Time is a physical quantity. So jihetu time tu ami kobo paru je keta bajle, so he karne time tu hoise eta physical quantity. But love is not a physical quantity. Eti ami janu je love tu hoise one kind of emotion. So emotion ketio measure koribo nwari. So he karne love to physical quantity nohoy. Clear everyone? Next we will see units. So units are a system of measurement. So it is a system or measurement of units buli koy. And we have two types of units. First one is MKS system and the other one is CGS system. Now this MKS stands for meter kilogram second and CGS stands for centimeter gram in second. Alright? Now this MKS system is also called SI system. So this SI stands for System International Units or Standard International Units. Now see here column, it is the SI unit of electric surge. So we will denote column by capital C and electric surge by capital Q. So etia electric surge or SI unit to hoise column, and this column is derived from the scientist Sir column. Electric surge is measured by column. So etia electric surge to column medi measure kore. Okay, so column to hoise eta unit. It is the SI unit of electric surge. Now see two like point charges. So like point charges mane hoise positive positive ba negative negative charges. Okay, and they have equal magnitudes. So a like point charges kitar magnitude equal, and they are placed in a vacuum, distance of 1 meter from its other. So etia a like point charges kitar major distance to hoise 1 meter, aru a like point charges kita kot ase vacuum ot rakha hoise. Okay, and these like point charges they repel. So আমি জানো যে positive positive কেতিয়াও attract নকৰে বা negative negative attract নকৰে. So they only repel, ইটোৰ পৰা হিটো আঁতৰি যায়. Okay, they move away from each other. 9 into 10 to the power 9 Newton, and each surge is called as one column. So এতিয়া চোৱা যেতিয়া one column or দুটা point surges 1 meter separation ত থাকে তেতিয়া সেই distance টোত এটা force experience হয়, and that is 9 into 10 to the power 9 Newton. Alright, now see the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. So this is the charge of an electron. আৰু তোমালোকে এই ভ্যালুটো মনত ৰাখিব লাগিব কাৰণ ফাৰ্দাৰ ক্যালকুলেশনছত আমি এই ভ্যালুটো ইউজ কৰিম. Okay, so this is the charge of an electron. Now see the magnitude of charge on a particle is given by formula Q equal to N into E. So এটা আমি জানো যে Q2 হৈছে electric charge. So small n it is the magnitude of charge and E it is the electron. Okay, now rearrange it and we will get N equal to Q by E. So this is the magnitude of charge. So etia next ami Q aru E value to put korim. So we know that each charge is called one coulomb, right? So it is 1C by so charge of an electron is 1.6 into 10 to the power minus 19 coulomb. So coulomb it will get cancelled. So we will get after calculating it N equal to 0.625 into 10 to the power 19. So further calculating it by removing the 0, we will get it is 6.25 into 10 to the power 18. So etu tumalike monot rakhibo lagibo a value to. This is the magnitude of charge. Now let us see another unit, that is volt. It is the SI unit of potential difference. So etia ami volt aru potential difference ei duitak ami capital V re denote korim. Okay, so potential difference or SI unit to hoise volt. Volt is a unit for measuring potential difference. So etia potential difference to measure koribo karone ami volt to use korim. So volt it is a unit. Now, okay guys, now see here, this is a circuit where V is the potential difference, Q is the charge, and W is work done. So work done in moving the charge. আমি জানো যে চাৰ্জটো যেতিয়া এটা সাৰ্কিটত মুভ হয় তেতিয়া তাত এটা work done হয়. So সেই work doneক আমি W denote কৰিম. So we will get the formula V equal to W by Q. So potential difference equal to work done by charge. আমি জানো যে potential difference or SI unit to হৈছে volt, work done unit to হৈছে joule, আৰু charge unit to coulomb. So volt equal to joule by coulomb. Now see here, 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. So it is basically 1 volt to hoise duta pointer potential difference. Okay, so jetia eta current carrying conductor 1 joule work done hoy tetia tat 1 coulomb charge to eta pointer pora hitu pointole move kore. Clear everyone? So etia 1 volt to hoise 1 joule per coulomb. So this is the unit of volt. You need to know the unit. Okay, okay, now tell me 1 millivolt is equal to, yes, it is 1 by 1000 of a volt, which is equal to 1 by 10 to the power 3 volt. So 1 millivolt equal to 10 to the power minus 3 volt, and 1 kilovolt equal to 10 to the power 3 volt, and 1 megavolt equal to 10 to the power 6 volt. So these are few conversions. Now let us see ampere. It is the SI unit of electric current. So এতিয়া আমি ampere to capital A ৰে denote কৰিম আৰু electric current to capital I. So electric current or SI unit to হৈছে ampere. Ampere is the unit for measuring electric current. এতিয়া electric current to measure কৰিবৰ কাৰণে এটা unit লাগিব, right? So সেই unit টোৱে হৈছে ampere. So this ampere is derived from the scientist Sir Andrew Mary Ampere. Now see here, this is a circuit where Q is the electric surge and T is the time. So from here we can derive the formula I equal to Q by T. So electric current equal to electric surge by time. So it electric current or SI unit to hoise ampere, electric surge or unit to hoise coulomb, and time to ami second dot consider korim. Okay, so ampere equal to coulomb by second. Now see, 1 ampere is constituted by the flow of 1 coulomb of charge in 1 second. So itia 1 second dot jiman 1 coulomb charge flow hobo hetui hoise 1 ampere. I hope everyone understood now what is 1 ampere. So now see, 1 milliampere is equal to, yes, it is 1 by 1000 of ampere, which is equal to 1 by 10 to the power 3 ampere. So 1 milliampere equal to 10 to the power minus 3 ampere. Clear everyone? Now let us do the maths the following. So I hope everyone knows now what is the SI unit of electric current, electric surge and potential difference. Yes, the SI unit of electric current is ampere, and the SI unit of electric surge is coulomb, and the SI unit of potential difference is volt. So eta mo kwa a joule to kihor unit? Yes, it is the unit of work done. Okay guys, now let's do some numericals. So these are type A numericals where we will be using the three formulas, that is Q equal to I into T, W equal to V into Q, and Q equal to N into E. So eta Q2 hoise charge, I it is the current, T it is the time, W it is work done, V it is the potential difference, N it is the number of electrons, and E it is the electrons. So I hope there is no confusion now. Now let us solve question number 1. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric surge that flows through the circuit. So এটা question to আমাক সুধিছে যে এটা ইলেক্ট্ৰিক বাল্বৰ ফিলামেন্টে যেতিয়া 0.5 এম্পিয়াৰ কাৰেন্ট ড্ৰ কৰে 10 মিনিটছৰ কাৰণে তেতিয়া হে সাৰ্কিটত কিমান এমাউন্টৰ ইলেক্ট্ৰিক চাৰ্জটো ফ্লো হয়. So basically ইয়াত আমাক চাৰ্জটো সুধিছে, ওকে, কিমান এমাউন্টৰ চাৰ্জ ফ্লো হয়. এটা ভিডিওটো তোমালোকে 2 মিনিটছৰ কাৰণে পজ কৰা, কোৱেশ্চনটো ভালকে পঢ়া আৰু কি দিয়া আছে হেকিটা উলিওৱাৰ পিছত তোমালোকে ইজিলি ফৰ্মুলাটো ইউজ কৰি সলভ কৰিব পাৰিবা. Okay, so we are given current I it is 0.5 ampere, time it is given in minutes, that is 10 minutes. So যেহেতু আমি সেকেন্ডত কনসিডার কৰিব লাগিব হে কাৰণে আমি মিনিটছক সেকেন্ডলে কনসিডার কৰিম. So we will get 600 second. So here we have to find the charge, that is the value of Q. Now you can use the formula, right, from the given values. So Q equal to I into T. So this is the formula we will be using. Now let us see the solution. Q equal to I into T. So ita ami I aru T er value kita janu, right? So now by putting the values of I and T and then solving it, we will get a value Q equal to 300 coulomb. So the charge flowing through circuit is 300 coulomb. So this is a simple formula based question. I hope everyone understood. Now see question number 2. How much work is done in moving a charge of magnitude 2 coulomb from a point at 118 volts to a point at 128 volts. So question to hodise je jete 2 coulomb charge to eta pointer pra hitu pointele move korute, that is from 118 volts to 128 volts, kiman work done hoy. So we have to find out the work done. Eta tumalike 2 minutes or karone video to pause kora aru nije attempt koribole try kora. Question to bhalke porha aru ki dia ase hegita uliai luar pisot it will be very easy to use the formula. Okay, now let me help you out. So we are given charge Q equal to 2 coulomb and potential difference V equal to, so it ami potential difference to a 118 to 128 or pra minus kori jiman pam hetui hobo potential difference. that is 10 volt. So we have to find out the work done, that is the value of W. So from here we will be using the formula W equal to V into Q, right? Now see the solution. এতিয়া আমি জানো যে V আৰু Q ৰ values কেইটা কি কি. So by putting the values and by solving it we will get work done equal to 20 joule. So this is the answer. So this is a simple formula based question. Now moving to question number 3. Calculate the number of electrons constituting one coulomb of charge, or so that 1 ampere is equivalent to flow of 6.25 into 10 to the power 18 elementary charges. So it was an easy question, already ami agote kori ahiso. So here we have to find out the number of electrons. So one column charge ot kiman electrons ase, that we have to find out. Okay, so we know that charge on an electron E equal to 1.6 into 10 to the power minus 19 coulomb. So a value to moi already agote koisu je tumalike monot rakhibo lagibo, karon calculation bilakot ami frequently use kori thakim. Okay, so this is the charge on an electron, that is 1.6 into 10 to the power minus 19 coulomb, and charge equal Q equal to 1C. So we have to find out the number of electrons, that is the value of n. Yes, we will be using the formula Q equal to n into E. It ami janu je Q2 hoise charge aru E2 hoise electron. So by arranging the formula we will get n equal to Q by E. So etia ami Q aru E values kita put korar pisot by solving it we will get a value of n equal to 6.25 into 10 to the power 18. So number of electrons constituting one coulomb of charge is 6.25 into 10 to the power 18. Easy one, right? Now see question number 4. How much work is done in moving a charge of magnitude 2 coulomb across 2 points having a potential difference 12 volt? So here potential difference to dia hoye ase already, that is 12 volt aru charge to dia ase 2 coulomb. So we have to find out the work done. Okay, now try to do it by yourself. Okay, so see here, given charge Q equal to 2 coulomb and potential difference V equal to 12V. So we have to find out the work done, that is the value of W. So again the same formula based question, that is W equal to V into Q. Now by putting the values of V into Q we will be getting work done equal to 24 joule. Okay, so this is the answer. Another easy question. Now moving to question number 5. How much energy is given to each coulomb of charge passing through 6 volt battery? Okay, so this is another easy question. Yat hudise je jetia eta 6 volt battery each coulomb of charge par hoy tetia he battery to kiman energy die. So energy mane hoise work done. So ami work done to yat uliabo laibo. So here we are given charge Q equal to 1 coulomb, because it is mentioned that it is each coulomb. Okay, and the potential difference V is 6 volt. So we have to find out the energy given by battery, that is the work done, right? So from here we will be using the formula, it is the same one, that is W equal to V into Q. Okay, now put the values and solve it. So we will get work done equal to 6 joule. Am I clear? Okay, so এইবিলাক সব formula based question, তোমালোকে just formula to জানিব লাগিব আৰু practice কৰি থাকিব লাগিব. Now see question number 6. How many electrons are flowing per second past a point in a circuit in which there is a current of 5 ampere? So এটা circuit ot যত 5 ampere current আছে তাত per second কিমান electrons flow হ'ব আমি হেতু উলিয়াব লাগিব. So we have to find out the number of electrons. Now pause the video for a minute and try to solve it by yourself. Okay, so see here, we are given current I equal to 5 ampere, time that is given 1 second, and charge on electron E equal to. Okay, now tell me what is the value for charge of an electron? Yes, it is 1.6 into 10 to the power minus 19 coulomb. So see how frequently we are using this value, right? So you should know it. So we have to find out the number of electrons, that is the value of n. So here we will use the formula Q equal to I into T. But etia a given values or para ami keneke number of electrons uliam. How we will find the value of n? So for that purpose we will use another formula, that is Q equal to n into E. Okay, now see the solution. So by marking both the formulas as equation 1 and 2, and after that equating both the equations, we will get I into t equal to n into e. Okay, so this q got cancelled after equating. So now rearrange it and we will get n equal to I into t by e. So now by putting the values, okay, so tumalike etia ei calculation to nije kora. Okay, let me do it for you. N equal to 31.25 into 10 to the power 18. Clear everyone? So electrons flowing per second is 31.25 into 10 to the power 18. So guys, so tumalike mainly concept build korat focus kora. Formula based question holo code keneke apply koribo lagibo, that is the main thing. So equation form koratue dangor kotha. Okay, hetu jodi para like it's well and good. Okay, now moving to the last question number 7. An electric heater is connected to the 230 volt main supply. A current of 8 ampere flows through the heater. So we have to find out how much charge flows through the circuit in each second and how much energy is transferred to the heater in each second. So at a electric heater ase jot 230 volt main supply logot connect kora hoise aru he heater tut 8 ampere current flow hoise. Okay, so ami he circuit tut per second kiman charge flow hoy hetu uleba lagibo aru heater tut kiman energy transfer hoy per second hetu uleba lagibo. Okay, now see here. So we are given the potential difference, that is 230 volt and current I equal to 8 ampere. Okay, now use the formula and try to solve it by yourself. So here given time is second, that means time equal to 1 second. So we have to find out the charge and the energy. Let me do it for you. So here we will use the formula Q equal to I into T. Since the values are given already, that is I equal to 8 ampere and T equal to 1 second. And to finding the work done, that is the energy, W equal to V into Q. So same easy formula based question. Now see the solution for A, that is Q equal to I into T. Now by putting the values and we will get Q equal to 8 coulomb. Now see the solution for B, W equal to V into Q. Okay, now by putting the values we will get W equal to 1840 joule. So this is the work done. So now say charge flowing around the circuit is 8 coulomb and energy transferred to the heater is 1840 joule. So guys, we are done for lesson number 1. In case you have any doubt, you can comment us.